Okay, mean and variance for negative binomial distributions. So the mean, same as the expectation, is equal to R over P, so that's the one we proved. And the variance is equal to R 1 minus P over P squared. It's sort of quoted in terms of P. I'm pretty sure these are in your formula book. 1 minus P is Q, so you could write that as RQ over P squared if you wanted to. I'm just going to go over one example. And again, it's the one out your book, just saving me a bit of time more than anything. So let's swap those. So you need to obviously be happy with those results. And there's example 5. So we've got Iona and Juan play noughts and crosses. The probability that Iona wins is 0.7. The random variable X represents the number of games that they need to play for Iona to win 7 times. Could be quite a while if they're only good at noughts and crosses. We won't worry about that too much. Right, so expectation and variance of X to start with. So X is negative binomially, God, I can't say that, distributed 7, 0.7. The expectation of X is equal to R over P, which is 7 over 0.7, which is 10. So that's your mean average number of games played for Iona to win 7 times. And the variance of X is equal to R, which is 7 times 1 minus P, which is 0.3 over P squared. And that's just popping into your calculator. So 4.286. So it's relative, oh no, it's, yeah, if you square root that, you're going to get about 2. So that sounds about right, doesn't it? I was going to say it's quite big for the standard deviation, but it's the variance. So variance is 4.286. They change games and start playing chess. The random variable Y represents the number of games that they need to play for Juan to win twice. Given that the mean of Y is 6, we want to find Juan's probability of winning a single game of chess. So Y is negative binomial 2, P. And we know the mean of Y is 6, so the expectation of Y equals 6. And so 2 over P is equal to 6, which makes P equal to 1/3. And then we want to find the standard deviation of Y. So we can find the variance of Y. I can fit this over here. Just move that board over slightly. Is equal to R 1 minus P over P squared. So again, you can just pop that into your calculator. That gives you 12. And so standard deviation so just to remind you, you can use sigma for that, and a subscript y, which is capital Y, is equal to the square root of 12, which is 3.46. So there's nothing too complicated going on there, it's just bringing in those formulae into some questions.